All right, and welcome back again, everyone. Our next speaker here in Verdino will be Severin Klingler. Severin is the director of the Media Technology Center at ETH, and he'll be telling us more about the center and the kind of work they do. So really excited to hear about that. Welcome, Severin.
Thank you so much. Good afternoon, everyone. It's a great pleasure to be here and to be able to talk to you about our center. I think I don't have to tell you that the media technology is undergoing a big transformation, mainly caused by digitalization. The way we consume media, we produce media, and also how we distribute media has drastically changed in the past couple of years. Data science and AI plays a growing role in this process. It has changed how we can create content, how we understand our users, how we can deal with text and video, and new ways of creating and supporting the creation process. However, there are still a lot of open challenges in this process. As we, for example, heard today from Didier, there's still unsolved problems that we could tackle. And this is where TX, together with Ringier, SRG, NZZ, and the Swiss Media Association, got together with ETH 3 years ago and created this Media Technology Initiative. And the goal of this initiative is really to strategically invest in research in the area of media technology. So they did this by establishing a new professorship in this area and by launching a platform for running collaboration projects between industry and academia to work together on some of those challenging problems. And this is the Media Technology Center that I'm going to briefly introduce you to today. So who is involved with this Media Technology Center? So we have a steering committee consisting of experts from academia and the industry. They're responsible for the strategic decisions and the strategic directions of all the projects we're doing. And on the other hand, we have the core center with our staff of researchers and engineers who are PhDs and interns who are actually working on this project. And I'm happy to be able to be the manager of this lovely team. What do we do? So we were founded in March 2019, and we've been growing quite a bit from 0 to 10 employees in this time, and the first project started in June 2019. We want to be a platform for exchange of ideas. That's why we have public lecture series, student seminars. We supervise a lot of students. We're offering a lightweight sabbatical programs for our partner. We also hosting various showcase events. But on the other hand, of course, one of the core things we want to do is do applied research projects, and we do these in 4 different areas, mainly in augmented reality, in natural language understanding and processing, video processing, and privacy-preserving machine learning. In all our projects, we're really working closely together with our partners. We're trying to incorporate both sides, the industry side as well, the academic side, to try to come up with good solutions to our problems. All our projects are pre-competitive. That means we're not doing individual projects just with one partner, but the goal is to have projects that are of cross-company benefit and that can drive the industry. All our projects are open access. We provide source codes for our developed methods. We, of course, publish our code and our algorithms. So what I want to do in the remainder of this talk is just present you very quickly some of the projects we've been doing in the past year. And I hope it gets you inspired maybe to reach out to us to do a project in the future with us. The first project I brought you is Augmented Paradise. In this project, we wanted to explore an augmented reality world, given that these augmented reality devices, such as the HoloLens or the Magic Leap, are becoming much smaller, and you actually want to wear them in everyday life. So we wanted to create a future vision of Paradeplatz and how this would look like. So the challenges here were how to bring information to the places you currently are, how and where to visualize that information, and how to provide tools for content creators. We created an easy workflow to prototype augmented reality applications on a citywide scale. And how this works is that you're creating the content in virtual reality. So you're wearing virtual reality goggles, you're standing virtually, for example, in Zurich on Paradeplatz, and you can start to create. You can draw, you can move around assets, you can just be very creative in this space. And as one example, you can see such a scene on the right-hand side of this slide. What we then do in the backend is we take this scene and automatically transform it onto the real place on Paradeplatz, such that you can watch it and experience that augmented reality, those augmented reality assets. We do this by aligning the virtual world with the real world. And we have to do this very accurately, that whatever you place in the virtual world is accurately transformed to the real world. And here you can see some of the examples. Of course, as you can see, none of us are artists, so we just tried to visualize a bit how this could look like with two scenes, an underwater world or this zoo-like creature. But it can really be any asset that you can dream of. Another challenge we wanted to solve is how can we place 2D content? Think of virtual billboards that we could place anywhere in this space. And we think that this is too tedious to actually manually place, so we wanted to find a way to automatically place this. So given a 2D content that you upload to our platform and you can select the viewing location, for example, the Paradeplatz, we automatically optimize the placement of your content in this new augmented reality space. And how this looks like is this is a screenshot from our tool. So you select the viewing point, this blue dot, and a viewing position and the viewing direction, and our system automatically creates a suitability map over the neighboring buildings where you can actually place the content and where it's most visible. You can do this also with selecting an area where you want your content to be visible, which makes it very easy to optimize for views. And how this looks like in real world is we're rendering this content onto the walls of the buildings. And as you go closer to those assets, you actually see different levels of details. So as you go closer, you see more information. In our next project, we wanted to recreate the newspaper from Harry Potter. You all know the newspapers, right? They offer almost video-like. People can act and react to you, and we wanted to recreate this experience. So the challenge for us is how do we do this with technology, and we chose the following approach. We took a paper and some content, and we wanted to render the content onto the paper such that it feels as natural as possible, and that you still have the tactility of a paper. The challenge, of course, is, as you're holding a paper, this can bend and turn, and you could even tear it apart, right? So we wanted to model some of that and be able to capture those things. So what we actually do is we use, and this is a very simple approach, right? We use markers on the paper to estimate the 3D position of some points on the paper, and then we create a 3D model of the paper you're holding in front of you. And with that information, we can render the content onto the paper such that it looks like as if it would be actually there. And this is just a simple visualization how this could look like. So you're holding a newspaper with an article about Hogwarts, and as you're bending the paper, the content neatly adapts. And what you have to imagine now is that this is a moving video, but of course we can play all kinds of media content onto these pages. So the sky is the limit there. In our next project, we wanted to explore how you would interact with news in an augmented reality world. So traditionally on the web, of course, the interaction is clear. You have websites, you interact through lists, or maybe a grid of articles, and you can select the ones you're interested in. But how would this look like in an augmented reality world? So what we try to do is, given a large article data set, how can we visualize this information? How can we make the access to news engaging? And what we chose for this was a news globe approach. So we have a 3D globe where you can see all the articles or a selection of articles that you're interested in, and you can browse that. What you can also do is you can easily see connections. So if an article is talking about several locations in the world, you immediately see this. Furthermore, we have a live view that lets you know what's going on in the world at this moment. So whenever something new is happening, one of those signs would fall down from the sky and tell you where something is going on. Of course, this can also be placed in augmented reality and allows you to place that globe in your living room or on Paradeplatz, wherever you like. And being a virtual reality application, you can also very easily interact with this globe. You can go closer to get more information. You can walk around the globe and see just what's happening. Okay, going away from augmented reality more towards text analysis, in this project we wanted to build an anti-recommendation engine. So what this meant for us is, imagine you're reading an article, let's say about Donald Trump, and you're happy with this article. Is there a way that we could provide a button that would say, show me the flip side or change view, and it would show you an article about the same topic, but from a different stance, from a different point of view. And the challenge for this is, given two texts, how can we decide whether they talk about the same topic and whether they agree or disagree on that topic? And our approach was using deep neural networks to, given two texts, to decide whether those texts actually agree or disagree. And what we found out is that on a news data set that we had, we actually almost reached human performance in deciding whether these two articles would agree or disagree. For other more challenging data sets coming from comments and debates, we were not quite there yet, but it was very promising to us. So we wanted to explore this idea a bit further, and our idea was to move more into the online discussion and commenting sections of websites. So at that time, we believed that a lot of the commenting sections are a bit broken. This is an example from the New York Times, where you have under an article over 1,000 comments. And of course, you can select the New York Times picks, reader picks, or you can sort it by newest or oldest, but it's very hard to find a comment that is interesting for you, especially if you're curious about different opinions or maybe something that is hidden in this large quantity of comments. So our idea was, can we somehow make it easier for the user to find interesting comments? And what we tried to do is basically classify all the comments according to different categories, such as sentiment, stance, the topic it's talking about, the style it's being used, or even the political view. And how this then looks like is, as you can see here, just an example for a commenting section. So the user would not only see the comments, but would be able to select, for example, stance and saying whether he or she is interested in for, against, or a discussing comment. All right, so in our final project that I want to talk about today, we wanted to build a Swiss voice assistant. All of you know many different voice assistants. They come in various sizes and forms, and they're great, right? They can make our life much easier. However, in Switzerland, they're not used that often. And we believe one of the reasons is that they don't speak our dialects, right? For me, it's still very weird. I feel like a stranger that I have to talk to them in High German. So in this project, we wanted to change that, and we wanted to enable these voice assistants to understand and speak Swiss German. And here you can meet our prototype of a Swiss voice assistant. It's built on a Raspberry Pi, so it's a very generic hardware, but we tried to improve on the software. What is going on behind the scenes of a Swiss voice assistant, or of any voice assistant, actually? So when you're speaking, you're generating a waveform, and this waveform has to be transformed by a speech recognition engine into a text. In this example, when I say, how is the weather in Bern tomorrow, I would generate this text, as you can see. Then you have an intelligence engine that takes this text and tries to identify the intent you have. Okay, you want to know about the weather. So, you call some API, you get the weather information, and you generate the text. For example, tomorrow in Bern, it's 19 degrees. What you then need is a speech synthesis engine that transforms this text back into a waveform to be able to hear it in the end. And for creating a Swiss voice assistant, we collaborated with Recap, a startup that actually already has a speech recognition engine for Swiss German, but we contributed the speech synthesis. So how can you teach a computer to speak Swiss German? And how we do that is in two stages. We first translate from the high German text to Swiss German text. So our model actually can translate you High German to Zurich Deutsch, to Bern Deutsch, to Walliser Deutsch, or to St. Galler Deutsch, which is quite fun if you watch some of the outputs. And then in the next step, we take this text and we synthesize the speech based on many recordings we did with voice actors. At the moment, our system can speak over 5 dialects, and of course, this is not limited to a voice assistant scenario. You can think of it using it in a podcast setting for reading news, reading weather forecasts, maybe even, as a moderator for some content. And if you're interested to listen to some of the samples, I recommend checking out this link below, or just our website in general. So that was just a quick sample of some of the things we're doing at MTC. There are many more projects that we're doing, and you can find out more about our projects in detail on our website. And as a final word, I mean, I already mentioned, right? We want to be a platform to run collaborative projects. So if you have any project ideas, if you have something that you would like to solve, but maybe it's not the right time yet, reach out to us. We have many possibilities to do projects, starting from doing projects with master students to bigger projects that run for several months. So if any of this sounded interesting, or if you have some questions, please reach out.
All right, thank you so much, Severin. Really, really interesting work. Cool to see what kind of things you're developing. We had some excitement, especially about the Swiss-German voice recognition. I would love to use this technology to transcribe my user interviews. When you get to that stage, let me know.
Sure.
So please leave your questions in the chat if you want me to ask them. And we have a question from Anton. He asks, what are the content authoring tools? What content authoring tools do you use within the AR projects you've presented? And are those tool chains openly accessible? Do they require some strong technical skills like Unity or C#? And can they be fairly simply picked up by designers? Let me know if you want me to repeat any of those.
No, sure. So that's a very good question. I mean, it was our goal to make them very easily readily available and easy to use for designers. So we're using Tilt Brush from Google on the VR device. So that's an app that you can just download. And everything else we're doing is kind of happening in the background. So the only thing you have to do is upload your models. So there's an upload dialog, and everything else is handled. However, this is really meant at the moment as a prototyping tool. So if you're interested, we can easily set up a square where you can test it, for example, in front of the TX building, and you can go crazy. But it's not something that you can use for, really distributing it to users yet.
Yeah. We have a few people in the chat just asking you to share links, so maybe double check the stage chat after this.
Sure.
Maybe I have a question then. So for me as a product person, I'm a UX researcher. When is the right time to approach you with a project idea or a support request?
I think there's never a wrong time. So what we're doing is, for the bigger projects, we typically approve them on a yearly basis. So, these are really the projects, some of them which I showed you, that run for 12 to 18 months. But if you have ideas in general, I mean, we're running basically on a rolling basis with starting new projects. Especially if you're doing something with master students. I mean, an ideal case is, end of the year or in summer, because then new students are interested in. But really, basically whenever you feel like you have something. And we're also excited to show you, of course, a bit more in depth what we're doing.
Cool, thanks. I'll wait a couple of more seconds to see if we have any questions coming in. Yeah, just curious if you also, following up on my own question, I guess, while we wait.
Sure.
So what kind of problems should we come to you with? Is it something like we want to solve this abstract problem and we need help approaching it, or is it really we need this technology? What is the best way to build it?
Yeah, that's a very good question. I didn't delve into that. I mean, basically what our team can do is applied research, but specifically in AI. So if you have something that is data related, and maybe if you're talking to someone in your AI teams, they tell you, not that it's too difficult, but maybe you don't have the time to delve into that. That could be something that is really, especially if something that's not yet there, that doesn't exist, that are the exciting projects for us. We're not good at software development. So if you have something, that needs a lot of software development, we're going to screw up.
Cool, thank you. I think there are no more questions. Maybe keep an eye on the chat to see if anything else comes in. Okay, so thanks again, Severin, for the really interesting talk. We actually now have a 30-minute break on this stage, so feel free to check out other tracks in the meantime, and we will be back at 4 p.m. with Thomas Grasch. So enjoy your break.